Hello, this is part 2 of my gripping series on the 2-day course I attended by the Canadian Nuclear Society on Nuclear Power 101, which is specifically designed to give people like me an overview of the nuclear power industry and actually to evangelise for nuclear power. But as we see from the opening titles, nuclear power has a bit of an image problem. First of all, I want to address risk. They made a big deal about hormesis theory, that small amounts of radioactivity is a stimulant and helps the human body be healthy. There is some research that does suggest that, but certainly once you get above 100 millisieverts, we start to have very, very bad reactions, both as a species and generally speaking on the planet. So we don't really want to introduce a substance that's going to produce over 100 millisieverts for us to take in without being very, very careful about it. So I don't know about you, but the level of risk I tend to use is the linear no threshold model, the LNT. This is any dose you get is an additive, the dose and the risk becomes additive with the dose, and there's no threshold for risk. I don't want any risk, like I don't want to take in anything that's going to cause me cancer. I'm not going to say a little bit's fine, I'm going to say I want no risk. And everybody's got the same risk. So they don't agree with that, and they kind of demolish that a little bit, but not that conclusively. In the hormetic model, dose is additive, we know that. The risk is not additive, so they're claiming that if you go from 10 millisieverts to 20 millisieverts, you haven't got 10 plus 10 amounts of risk. Yeah, but certainly when you get to 100 millisieverts, going from an increase by 10 isn't the same as 0 to 10. It's the difference between life and death. Low dose may reduce risk. Well, maybe, we don't know. But again, we're natural creatures, and we're not all the same respect to risk. Now, there are parts of the world that have huge amount of natural form radiation. They do solid okay in those areas. That's the argument that people genetically develop and animals genetically develop to those areas. Now, agreeing with the public perception, they use certain sound bites and they talk in certain ways. They talk about airline crew have melanoma skin cancer, but when it was studied it wasn't anything to do with the increased radiation that they get, which is considerable for transatlantic crews. They claim it's entirely due, or at least they suggest it's entirely due to sunbathing at stops. That may not altogether be true. They use astronauts to show that there's no direct correlation with high background radiation and cancer. Again, I would like some more studies on that before I accept that. They say everybody's entitled to their own opinion but not their own facts, and that's true enough. But the facts are there's been multiple bad nuclear power peaceful use accidents that have caused huge stress and loss of life. Now they claim the loss of life is minimal, but they're not looking at various other factors, which I'm going to get into. So they use false evidence appearing real, FEAR. I think this does have quite a bit of applicability to modern day life politics and even our sport, our hobbies. All radiation is harmful. Radiation only happens as a product of human activity. There's no good way to detect radiation. Radiation is the biggest cause of cancer. There is no safe way to work with radiation. Radiation radioactivity will cause cancer just by being near it. 1 million people will die because of Chernobyl. Now that's an interesting one. If you work with a parachute, the parachute is not dangerous to you. But if you jump out of a plane without a parachute, then it probably will be dangerous. If you drop a parachute out of a plane and it lands on somebody, then it's harmful. The risk of throwing the parachute out of the plane and hitting somebody on the head and killing them is fairly small. That does not necessarily therefore mean we should be going around throwing parachutes out of planes. So they have to prove a case. They have to prove that no matter what happens, worst case scenarios, the actual effects on humanity is much less than the effects that we would experience by not using nuclear power. Now, as I've said before, coal and oil, forget the climate change stuff, though that is significant in terms of human disaster and loss of life, but just by breathing those particulates in, we're losing probably about 600,000 to 1.6 million people a year at a conservative guess. This stuff is very hard to know specifically. So it makes a logical sense that if the cumulative risk year on year out is 1 million people die from nuclear power, the side effects of nuclear power by accidents and others, that's okay, because it's better than the alternative. And that's possibly true. And yet we also have a alternatives called solar power and wind generation, they point out, and I thought it was kind of amusing, that people die constructing those panels by falling off roofs. They do. But unless they land on somebody, their effect on other people around them is reasonably limited. If a nuclear power station experiences Chernobyl or a Fukushima or a wind scale or a 3 Mile Island effect, and there's been others, it affects a lot more people, and those people get upset. Very upset. They claim 28 workers died from radiation poisoning at Chernobyl. They claim that 15 patients have died since Chernobyl in 1986 from thyroid cancer, and they claim there's a potential for 4,000 more thyroid deaths. That's fairly small in terms of what a coal power plant would do over that period of time. Other people using other facts have pointed to 1 million possible deaths. One of the things they haven't pointed to, and I didn't bring it up, was the fact that the Ukrainians have done their own scientific research, and when you look at death rates and birth rates across Northern Europe before and after Chernobyl, there's a very obvious reduction in births in the million range. So one can claim that the higher risk of, probably from Chernobyl, there was a lot of cesium, the risk of that is actually killing an unborn baby that would have been born alive. I think a lot of people would argue that's a death. They do not. And the fact that they claim 28 people only died in Chernobyl is kind of bizarre to me, given the fact of what we know. It wasn't the evacuation deaths, because the evacuation done very well. A lot of people died. Remember, in Belarus, they had people living there till 1999, fully 12 years after 1986, almost 13 years, living with incredibly dangerous amounts of radiation in their food, their water, and their air, and their soil, and in fact on their homes for a long, long time, and nothing was done about it. And there's clear evidence that there is an incredibly higher rate of mortality. And one of the things they also talked about, though they were cautious with that, was the huge beneficial effects from the loss of humanity around Chernobyl in terms of the wildlife. And yes, that is an effect, and yes, I've discussed it before, and it does appear at this point that the majority of animals that are living in Chernobyl have migrated in there from areas around where there are humanity. But the actual ability to maintain population base by breeding without radiation effects in the Chernobyl exclusion zone appears low. Nobody died at Fukushima directly from the radiation effects. There was a lot of people died from the tsunami. They claimed 2 died because of suicide. They claimed there was 28 deaths from accidental evacuations, and the premature deaths among evacuees was 764. That's kind of interesting. Now, Futobote Hospital was 4 kilometers from the reactor that exploded. Remember, there was more than one reactor that exploded. They did not really kind of mention that very much. 4 died during the evacuation out of that hospital, and then 40 died subsequently in the gymnasium they were placed in. That's fairly typical. When you have geriatric long-stay patients and you emergently evacuate them, they do tend to die. So despite being well up and versed in all of this stuff, they forgot to mention that the first definitively worker death from radiation exposure at Fukushima happened in September of 2018. The last day was taken up by an educator who's got a science background, Larkin Moskrop, and she works with the nuclear power industry, and she titled her day Nuclear 101, Why the World Has Nuclear and Needs It Too. Case closed, okay? So she talks about the history of nuclear power in Canada, the fact that when the Clark River was decommissioned, that they threw it in sand because the idea at the time was dispersal, and that's why there's a tritium stream coming out of Clark River to this day. She talked about how safe it is and how people aren't really that bothered about it. It was all very, very reassuring. So the NRX reactor was built in 1944, started construction then, as part of the Manhattan Project to drop nuclear bombs on Germany. We ran out of time for that, but then on Japan. But there was a meltdown of that reactor, and that reactor was buried in sand, like I say. There's no discussion about long-term death rates from the workers involved in that because they probably didn't track it. And that again concerns me. But people die in the petroleum industry, people die in the trucking industry, people die in healthcare. The question is, the real question that the nuclear power industry has to answer is, can they avoid killing large numbers of people. And that's what they focus on. But for me the real question is, can they avoid removing millions of acres of fertile land from human production and animal use? That's the real question. Because if you are going to progressively have accidents, say we only have one accident every 100 years, and over 1,000 years we have 10 accidents, and each accident is like Chernobyl, I'm not sure that's a cost worth bearing if we can use wind and solar. They dismiss wind and solar. I'm not altogether convinced that the amount of money put into that is true. They actually put the generation of power for wind as the same cost as nuclear, but obviously is not as long and not as sustainable in terms of generation capacity. But solar was mostly, as I've said before, dismissed. We also seem to forget that humanity is not that smart. When they first built the CANDU reactors, the type of zirconium they used so they could put them in horizontally, which is better than anything else the world's got, even though the rest of the world's not really using that, actually rusted with the hydrogen. The hydrogen got into it and rusted it, and they almost had a disaster. But they found it, and then they switched to a different type of alloy, so that's fine. So I think that's the concern I think most people have, is this is very new technology. And new technology is worrisome if the risks become apparent during use. There was no suggestion, there was no talk that any risk from nuclear power had actually been uncovered prior to generation. And that for me is worrying. We're leaping ahead, we're doing all sorts of crazy things, and we'll get to that as well.